Hello everyone, we're back for the next topic. Today's topic is medians and altitudes of triangles. So in the last section we looked at some of the bisectors and understood what those points of intersection were called. In this section we're going to look at medians and altitudes and talk about kind of the same idea. So a median is the segment that has the endpoint on the vertex and the midpoint of the opposite side. So you've got this picture here that you hopefully can see below. The median goes from one of the vertexes to the midpoint on the other side. So what that does is it creates two congruent segments on that line. Okay, so for that one you've got there, this green line would intersect and cut that segment into two congruent parts, and then the red line would do the same thing, and we've got that there. So those are your medians. They cut those things from a vertex to the midpoint on the opposite side. Now what ends up happening is we have all of those that intersect at a single point. You can see there is my single point. That single point is what is called the centroid. Okay, so that's a centroid. Now what that leads to is what's called the centroid theorem. And it says the medians of a triangle intersect at a point called the centroid that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So you've got this intersection here, which you can see in this picture. And what this shows is that from the midpoint to the centroid, and then from the centroid to the vertex, has a relationship. And that relationship is 2 to 3. Okay, so 2 goes to here, 3 would be that whole part. So you can set that up as a ratio, or just use what I've got over here on the right. So if you look at the right, it shows you that AG, which is the value from the vertex to the centroid, is 2/3 of the entire AF. BG is 2/3 of the entire BD. And CG is 2/3 of the entire CE. So with those values being 2/3, what we can do is we can solve some problems and get some values. So for this first one, it tells you that AF is 15. So from A all the way up to F, we have 15. They want to know what is AG and what is CF. So a couple different ways to do that. If we know that that whole thing's 15, I can take AF, and remember we've got this ratio, or this relationship right here. I can say that AF is 15, so AG equals 2/3 times 15. And so you solve this out. You take 15 over 1, multiply straight across, you got 30 over 3, which is 10, and so AG is 10. And we've got that. Well, since AG is 10, the whole thing is 15, that means that GF would have to be 5, or 15 minus 10, and there's that. You could even do that using that segment addition postulate. Alright, now the second one says the EG is 10, so this part here is 10. I want to know what is CG and CE. Well, since that one's 10, that's the shorter part. Okay, as well as we saw in the last one, this is 2/3 the whole thing. Okay, so if that's 2/3 the whole thing, this one has to be double that one. Or you could say that this part here, this EG, is 1/3 the whole thing. So CE is equal to 1/3 of EG. Well, we know what EG is. EG is 10. So you've got 1/3 CE equals EG, which is 10. If we solve for CE, that means we're going to multiply by the reciprocal, which is 3. Those two cancel, and CE equals 30. Well, since we know CE equals 30, CE is the whole thing. EG is 10. That means that CG has to equal 20. And there's your solution. Alright, so that's the median. The median goes from a vertex to the opposite side, cuts it in half, and has a 2/3 ratio relationship. Alright, the next one is what's called an altitude. Now the altitude is the segment from the vertex to the opposite side meeting at a perpendicular angle. So we have to have a 90-degree angle here. And that's the key. It has to be 90 degrees. It doesn't matter where it meets as long as it is 90 degrees. So I put a couple examples down here. Okay, so here you've got the vertex drops down to the opposite side and it meets at a right angle. That's your altitude. Okay, now on a triangle like this, this is an obtuse triangle. When you drop this down to the opposite side, notice where it meets. It meets outside the triangle, and that's okay. Okay, if it meets outside the triangle, that's not a problem. Okay, so what we've got now is the intersection of these altitudes. Well, the intersection of the altitudes is what's called the orthocenter. And what ends up happening from time to time, and I'm going to try and sketch this. It may not be the best sketch, but when you take these and you create these right angles, and you assume you got a right angle, you've got this orthocenter right there. That's where the altitudes intersect. Now sometimes these things intersect in different places. So you can see with this one, if this is a right triangle, from this vertex down this way, I've got my orthocenter right there. Okay. The other one, I would take it and drop it down this way. Well, what's going to end up happening is this thing can continue on, this one could continue on, and this other one could continue on, and they may intersect inside or outside that figure, and everyone's just going to be a little bit different. So you have to understand that these things can change. It's much like that circumcenter and values that we found in the last section. Okay? So in this section we've got the centroid, intersection of the medians, the altitude has an intersection of the orthocenter, and then in that last section we had some other ones. Alright, so we've got all these different values. Now the examples you're going to see are something like this. So identify if the pictures are examples of altitudes, medians, or perpendicular bisectors. So altitudes, remember, meet at 90 degrees. Medians cut in half. And perpendicular bisectors are 90 degrees and half. Alright, so let's check it out. Well, for this first one of the sailboat, you can see that it drops down. There is definitely a 90-degree angle. We're not sure if it actually bisects it or cuts it in half, so we can't say for sure. So this one's just going to be the altitude. Now for the second one, we know that we have congruent parts. Okay, so it does bisect it or cuts it in half. It comes from the vertex, which is a good thing, but we don't know for sure if that's 90 degrees, and we're not going to assume. So this one's just going to be a median. Now the third one on the baseball diamond, you can see that there is a right angle. You can see that these two are going to be congruent. So since we have the right angle, means it is perpendicular, it is cut in half or bisected, this is a perpendicular bisector. Alright, finally, for this last one you can see that you've got these congruent parts. It's coming from a vertex. It does not necessarily cut it in half, so we can't make that assumption, and so that one's just a median. Alright, so that's what you're going to look at in this section. You've got the orthocenter is the intersection of the altitudes. You've got that centroid is the intersection of the medians. So go through, work through your numbers. If you need some help, let me know. Otherwise, good luck.